Welcome to Spring LIB.
Hi everyone, so what we have here is a tractor that is moving at a velocity to the right of 4 meters per second, and attached to that tractor is a rope which goes over a pulley and is being used to lift this mass B. We know that the mass B has a mass equal to 150 kg, and this mass is being lifted over with the pulley. What we're asked to solve for is to find the tension when this distance SA, which is defined as the distance from the mast to the tractor, is equal to 5 meters. So what we're going to be doing to solve this problem is defining the length of the rope in terms of SA and SB, and then be applying Newton's second law to solve for the acceleration of the block to solve for the tension when SA is equal to 5 meters. So let's go ahead and draw a diagram of just this rope. So this rope shown here, which is going to be equal to a length equal to 24. We know that this distance from the box to the tractor is SA, and we know the distance from the ground to the box is equal to SB. Therefore, this height will be equal to a value, but we know that the total distance from the top of the pulley down to the ground is equal to 12 meters. Therefore, this distance here is just going to be equal to 12 minus SB. What we can do is we can say that L, which is equal to 24, will be equal to 12 minus SB plus the square root of SA squared plus 12 squared. And that is just the hypotenuse of this triangle. Next, what we can do is go ahead and differentiate this entire expression with respect to time to obtain velocity. So by taking the derivative of this expression here with respect to time, we see that dl dt in terms of SA and SB is going to be equal to 0 minus SB dot plus SA times SA dot all over the square root of SA squared plus 144. Now we can go ahead and take the derivative again to obtain acceleration. So we can say that the second derivative of L in terms of SA and SB will be equal to negative SB double dot minus SA dot the whole squared all over SA squared plus 144 raised to the 3/2 power plus SA dot squared, the square root of SA squared plus 144 plus SA double dot times SA all over the square root of SA squared plus 144. And remember that this is equal to 0. So this is the expression that we have here. Now what we can do is actually go ahead and just solve for SB double dot, because that is the acceleration at point B. So what we can do is we can say that SB double dot, which is just equal to the acceleration at B, is equal to SA squared, SA dot squared, all over S squared plus 144 raised to the 3/2. Make this a little nicer, raised to the 3/2, plus SA dot squared, all over the square root of S squared plus 144, plus SA double dot times SA all over S squared plus 144. These are all SA. So we can evaluate this when SA is equal to 5, because we know that SA is going to be equal to 5. SA dot is equal to the velocity of the tractor, which is 4, and SA double dot is equal to 0. So this term actually goes away. And what we're left with is an acceleration of b, which is equal to 1.049 meters per second squared. Next, what we can do is we can apply Newton's second law to find the tension on the box. So we have our box here. We have a tension force, and we have a weight force. We're going to be assuming that these are the only forces acting on this box. And as we do Newton's second law in the y direction, we can see that tension minus weight is equal to ma. Therefore, the tension is equal to the mass times acceleration plus the weight. We can go ahead and take out the mass and say that this is equal to a plus g. Remember that we know the mass to be equal to 150 kilograms. We know the acceleration that we just solved for is ab, and we know gravity. Therefore, we can get the tension force to be equal to 1.63 kilonewtons. And that's our final answer.